Hello, and thank you for joining us for this workshop with ISBA. We're glad to be part of the convention. My name is Dan, and I'll be running through this workshop with you today. I want to share my screen here so you can see what we're going to be talking about. This presentation is titled Better Air Through Science, the Power of Ions, Effective, Safe, Affordable. And so we're going to be talking about a technology called Needlepoint Bipolar Ionization, manufactured by Global Plasma Solutions. I want to introduce you to a few people, starting with myself a little more in depth. My name is Dan Russell. I'm a licensed mechanical engineer in the state of Idaho. I work for Norbert Equipment Company. We are an HVAC equipment supplier serving all of Idaho, and we are the representative for Global Plasma Solutions in the state of Idaho. So any questions you have or follow up, more detail you'd like on the technology, you can follow up with us. And there's my contact information. Two other gentlemen I want to introduce you to. One is Mike Wheatonay. He is a former school board trustee member with the West Ada School District, over 18 years with them. And then Mr. David Shirk, who's got 38 years of experience in the HVAC equipment industry, a lot of experience in this with this technology specifically, and he is now the business development director for Global Plasma Solutions. So those two guys can be resources for you as you move on from this workshop. Unfortunately, they're not able to be part of this recording, but we do hope to have a webinar including both of them in the near future. So with that, I want to take you to a disclaimer slide because we are talking about indoor air quality in the world of COVID-19 and a pandemic. I want to make sure we're not communicating that this technology replaces or eliminates other key measures such as social distancing, face coverings, things like that. We're talking about the HVAC system, how we can make cleaner air, and how this technology can complement what's already in your buildings and the procedures you're already going through. So keep that in mind. The way I'd like to start is by showing you a video. And this is going to give you an overview of what we'll dive a little bit deeper on in the workshop itself.
Have you ever heard someone say, "Let's go inside to get some fresh air"? Probably not, and it's for good reason. On average, we spend 90% of our time indoors. But according to the EPA, indoor air is often 2 to 5 times more polluted than outdoor air. In fact, many of the buildings we occupy could be harmful to our health without us ever knowing. Hidden molds, off-gassing from chemicals or furniture, even people are just a few of the sources that degrade indoor air quality. So it's no wonder we go outside for fresh air. Outdoors, naturally occurring ions are everywhere and are constantly working to clean the air. Ions are created with energy from rushing water, crashing waves, and even sunlight. Unfortunately, the concentration of these naturally occurring ions is much lower indoors, where particles are often suspended in the air. These particles can include dust, dander, pollen, smoke, and even pathogens such as mold, viruses, and bacteria. The risks associated with inhaling bacteria and viruses may seem obvious, but even common dust and dander can cause respiratory issues or worsen pre-existing conditions such as asthma and allergies. There's still hope for indoor air quality, though, thanks to ionization. Our patented Needlepoint Bipolar Ionization technology safely introduces ions into the airstream using the airflow in your existing ventilation system as the delivery method. When these ions disperse throughout a space, such as an office or a schoolroom, they combine with particles suspended in the air. This creates a snowball effect in which particles of opposite polarity begin to cluster together. As these larger clusters pass back through the building HVAC, they're easier to capture in the filtration system. Our cleaning process is also effective against pathogens, as contact with ions disrupts pathogens' surface proteins, rendering them inactive. Other common indoor air pollutants include VOCs, or volatile organic compounds. There are hundreds of types of VOCs that are created by common household items, such as cleaning chemicals. Ionization is effective at eliminating VOCs as well as odors, such as those lingering around nearby trash. Through our patented technology, VOCs and odors are broken down into basic, harmless compounds, leaving the air smelling fresh and clean. You can also feel confident knowing that, unlike many other products, Our ionization cleaning process will not introduce ozone or other harmful byproducts into the air you breathe. Today, our technology is trusted to safely clean the air in hundreds of thousands of installations, including offices, schools, airports, hospitals, and other community spaces around the world. So now, we can go inside to get some fresh air.
So I hope that was a good overview for you, and a lot of what you'll see in the slides to come are going to be representative of what you saw in the video, just a little bit deeper. So to give you an overview, we're going to highlight who Global Plasma Solutions is. We're going to talk about the types of facilities that we've already got installations in, and then what is the technology? What is needlepoint bipolar ionization? How does it work? What are the results? What are the safety concerns? Et cetera, et cetera. Move forward a little too quick there. And then at the end, we'll take a look at what the products are. So we'll spend the bulk of our time on the technology itself, but then we'll look at some of the specific products. What do they look like? How big are they? Where do they go? Where do they get installed? And then we'll look at some case studies towards the end. So about Global Plasma Solutions, really GPS is about solving indoor air quality problems. And they've done that in a pretty unique way through patented technology. They've been the innovators in this technology. A lot of other manufacturers who do similar devices reference GPS testing data. And they really are the forerunners in this class of technology. And it really is all about indoor air quality, making the air safer inside so that we can get staff and students back into schools. That's really the objective for a technology like this. And as you saw in the video, indoor environments can be 3 to 5 times dirtier than outside air. And so typically the strategy is to bring in outside air to flush out the contaminants that are inside the space. But with ionization, what we can do is replicate the cleaning aspects of outdoor air, the reason why they're so clean, which is from the ions, and bring that indoors. So really, we can have this idea of going indoors for fresh air. And then another important aspect we're going to spend some time on is that needlepoint bipolar ionization is safe and does not have harmful byproducts. And in particular, it does not generate ozone. That's one of the things you want to watch out for with this type of technology is a lot of devices out there do produce ozone, which is not healthy. So we'll talk about that. Something unique about GPS is that they're the only technology of this kind to be approved by the FAA for use in aircraft. And they're under negotiations with some commercial carriers, and definitely have lots of installations in private carriers, especially some of the most VIP private carriers in the world, if you know what I mean. Lots of different applications, places that can be installed, big spaces, small spaces, lots of people, small amounts of people. And so very versatile. That's one of the things you'll take away is that the technology and the devices that GPS manufacturers are very versatile. We can apply them in almost any existing system. And so here's some facilities where the technology has been installed already. A lot of big names there. Universities are huge on it, and airports actually, they use it to eliminate fumes from the jet fumes from the jetway and the tarmac. So power of ions. Here we're going to talk about the technology, what it is, and what it means to you. So first thing to understand is that ions do occur naturally. They occur outside. Positive and negative ions are generated a number of different ways, either by crashing waves, running water, at high altitude, after a thunderstorm, near the ocean, all the places that we would associate normally as having good, clean, fresh air, where we would want to go and feel like we're out in the nature's fresh air. In those places, the ion counts are much higher. And so that's what we're trying to achieve, is to bring that outdoor environment indoors. The problem is that indoors, the concentrations are typically much lower. And so we want to do what we can to generate some of those harmless ions to fill the indoor spaces like they are outdoors. And that's really the objective with the technology. So ionization is the process of using voltage to electrically charge air molecules. And by doing so, we can create this cleaning effect. And so some of the comparisons against other technologies, air cleaning technologies, you might consider. There's a couple of other ionization technologies, just general bipolar ionization, or what is called corona discharge. The advantage we have with GPS over those is no harmful byproducts is number one. Those other versions do create ozone. And then some other features that GPS is really focused on to make them kind of hassle-free, zero maintenance, very low energy, and very simple to install and apply to existing buildings. So you see some other strategies there like HEPA filters, carbon, ultraviolet, and you can see the advantages that ionization has on those. I want to focus a little bit more on what the ion density is about. And so when we talk about counting ions or measuring ions, we count them in ions per cubic centimeter. And that's the metric we use. We have digital counters that count the ions in a space. And then we can compare to know what the cleaning impact would be of that space at the particular ion count. So as an example, this is a movie theater facility where the initial, let's see if I can get my spotlight tool so I can show you some things here. Yes, so if you look here, this is two different spaces in the theater, two different auditoriums. One has an initial total ion count of 2,000 ions per cubic centimeter. You can see the split here. The first light gray bar is positive ions. The second gray bar is negative ions. So that's the baseline. Before installing ionization devices, this is what the spaces have. About 2,000 in this space and about 5,000 ions per cc in this auditorium. And then after installing GPS ionization, they measured 5 different locations in this auditorium, and it looks like about 7 different locations for the larger auditorium. And you can see how the ion counts increased as a result of adding those devices. So we're seeing on this auditorium an increase to about 4,500 at a minimum. So from about 2,000 to 4,500 all the way up to almost 7,000. And in the case of this auditorium, some locations are measuring up around 20,000 ions per cubic centimeter. And that's hugely significant because that means the cleaning capability of the air in those spaces has gone up drastically as a result of adding these ionization devices. And that's really what it comes down to, is the more ions we get into the space, the more cleaning impact we can have. We'll talk a little bit more about how the direct correlation between ion density and cleaning impact later on. But first I want to talk a little bit more about the safety of the devices, why we feel comfortable using these in indoor spaces, and that's because we're not generating ozone. Needlepoint bipolar ionization is relatively new, maybe 12 to 15 years old in the industry. But what's important to know is that ionization itself has been around for 140 years. The difference is that it's taken this long to figure out how to manufacture the technology in such a way that it's safe, that it doesn't produce ozone. And that has to do with how much voltage is applied to the emitter points. There's a lot of technical detail in there we won't go into in this workshop, but I just want to let you know that ionization as a general principle has been around for a very long time, but now we've gotten to where we can control that process so that we don't produce ozone and no harmful byproducts, because ozone is a harmful byproduct and we don't want it in our spaces. So that's why if we go back a couple slides, actually want to highlight this. One of the key standards is called UL 2998. Some of you may not be too concerned about that, but what that means is that it's tested to a very strict standard to be ozone free. And we want to be careful to watch for the 2998 specifically, because there's another standard out there called 867, which was the first one to be adopted by many manufacturers, and most manufacturers comply with 867. The problem is that 867 is not very strict for these types of devices. They're really designed for portable air purifiers like you would have in your home, and not designed for these commercial type air cleaners. So because of the UL 2998, GPS is able to achieve very high ion outputs at safe levels, whereas in most other cases, ionization products are not able to do that. So wanted to just let you know about ozone, and something that GPS offers may not be too applicable to you, but just as a principle, they have a lab. They welcome anybody to come test their equipment. That's how certain they are about their product, how it stacks up against others. And also, if you just want to go test it for a particular reason or see it in action, they open their lab for that reason. So that's an invitation GPS puts out. Now, about needlepoint bipolar ionization and how it works. There's really three key functions and one side effect, I think, of the technology. But the three things it does, number one, is it targets particles. We're going to talk about that coming up. But basically, it can reduce the size and quantity of particles floating around in the airspace. That becomes really important. Secondly, which is very important now with the pandemic and COVID-19 concerns, is that it reduces pathogens. It attacks protein. The ions can attack protein layers on bacteria and virus molecules so that they are directly deactivated. You don't require recirculation through a filter or anything. They can directly deactivate pathogens within an airspace, and that is key. The last thing is with odors and VOCs, the ions break down those chemical compounds so that the odors break into more less objectionable components like oxygen or water vapor. And so if you've got formaldehyde or ammonia or other off-gassing that's happening inside a school space, then ionization will help eliminate those odors. That's really awesome. And then that fourth thing is that through these functions, one of the aspects is that there's potential to reduce outside air because we're directly cleaning the air rather than needing all that dilution air from outside. And so traditionally, ionization has been used to be able to reduce the outside air amounts within a space. However, right now during the pandemic, we're not recommending that as a mode of, as a key benefit, because we want to still keep outside air. We want to use these measures in concert with one another. But also on the energy side, we'll talk about comparison to other products for when we're comparing ionization to increased filters, UV lights, and those types of things. The power consumption of ionization compared to the others is very low. And so that can be a potential energy savings right there. So let's talk about particles. Okay, so the smaller the particles in the air, the more dangerous they are because they can reach deeper into the lung tissue of humans. And so floating around in our airspace, you've got dust and pollen and dander and smoke and pathogens. And they float around. In a lot of cases, they're so small that they just stay suspended in the air. They don't fall out onto a surface to get cleaned up. They don't have enough surface area or buoyancy to get caught up by the return air system. So they just hang out until something comes along and attaches to it or someone breathes it in. And so what we can achieve with ionization is this idea of agglomeration, which is going to take those particles that are very tiny and cluster them into a little bit larger particles so that then the filter system can remove them. Because when you cluster them together, what happens is instead of staying suspended in the air, they either cluster up big enough to fall out of suspension and fall into a surface, or they become buoyant enough that they can be captured by the return air system and circulated and filtered out. That way, they don't just hang out in the space. So what I want to show you here is a little video. It's a tabletop demonstration of a cigar or a canister with cigar smoke in it. And those two needles, we call needle brushes, right here and here, those are emitting ions. And at the beginning of the video, let me see if we can go back here. Just restart it. So you can see right now the canister is full of smoke. As soon as they turn on the ionization device, those emitters begin emitting negative ions and positive ions, and they begin clustering those smoke particles immediately. And as those smoke particles cluster together and get heavy enough, they fall out into the bottom of the canister, which is why you see the canister clear up. And then as they try to pump more smoke in, the ions that are already there are clustering those smoke particles as they get delivered into the space. So they have no chance to just sit around and make the room smoky, or the canister in this case. Obviously, this is a much smaller case, but the principle is very visible here in this demonstration. And this is what's happening with ionization, is taking those tiny particles that just float around, clustering them together so that they can be cleared out of the space. That's one big key advantage of ionization to be aware of. And that comes into play with some of the other benefits as well. You can see here this filter, if you remember from the video, it showed the small particles clustering together into larger ones, and those larger particles get captured by that filter. What's cool about it is that it can cause your existing filter to behave like a more efficient filter than it is without having to upgrade the filters. What I mean is a certain filter rating, let's say a MERV 8, and there was a study done in this case, specific case exactly. A MERV 8 filter is a very standard commercial air filter for kind of minimum level filtration. And so what happens is there's smaller particles in the air than will get caught by a MERV 8. A lot of particles, especially those that are infectious, will just pass right through a standard filter, which is why you see organizations like ASHRAE recommending to upgrade your filters from MERV 8 to MERV 13, which is a great idea. In this lab study, what they did was they took a MERV 13 filter and showed how clean it gets a room, basically showing what size particles and how many there are after you run the MERV 13 filter for a while. And then in the second parallel example, they started the room with the same amount of particles and then ran a MERV 8 filter with ionization. And over a period of time, you see the room come down to the same size and quantity of particles as the MERV 13 achieved. And so what they see is about a 4 to 5 filter rating increase when applying ionization. And this works for any existing filter system. So if you're going to have a MERV 8, you can increase to a MERV 13. I'm getting ahead of myself here. And if you have MERV 13 filters, let's say your facility is already upgraded to MERV 13, the addition of ionization just continues to improve upon that. And you end up with something around a HEPA level, or MERV 17, which is like hospital grade filtration. And so they really work complementary. The ionization works complementary with filtration. So they're not competing strategies as the main idea there. So why do we care so much about particles when it comes to pathogens and virus? Well, one key thing is that the viruses will attach to a particle. Let's say you have a virus that's very small and it tends to float around. But if there's larger particles moving through the air, those viruses will attach to the particles that are larger and move through the air. So that's one important reason as we transition from talking about particles to pathogens. So one way that pathogen control occurs is through that agglomeration, and reducing particles. We're going to reduce how much pathogen can be transferred through the system. Let's talk about how needlepoint bipolar ionization can reduce the spread of disease directly. And this slide I love because it illustrates what we've all kind of come to know as the shape and design of the SARS-CoV-2 virus. You see it's got the surface lipid membrane here, and then it's got these spike proteins. This is a positively charged virus naturally. So when we bring negative ions in particular, the negative ions are going to do a few different things. Number one, it will rob the surface of some hydrogen molecules that are necessary for this to survive. And when it does that, it breaks down these proteins and exposes the RNA inside. The RNA is the information that allows this virus to replicate. And so what's going to happen is the virus can be directly deactivated by the ionization, the negative ions in particular. Again, we talked about agglomeration. And so that's with the particulate control. That's another means of effectiveness. So it's going to actually filter out more of the pathogens that are there. And then a third consideration is something that we've just recently heard about out of the Northwestern University, a study by the university there that has observed the SARS-CoV-2 virus strain has positively charged receptors here at the surface, and those tend to attach themselves to humans at the negatively charged human cell receptors. And so what they're saying is, if we can neutralize the polarity or the charge of the virus, there's no way for it to attach itself to the human body, to the human cell receptor, because that's where the actual infection begins. So you can have the virus floating around inside the body, but it's not effective until it attaches to the receptor. At least that's our understanding of that study coming out. And so, as you may be aware, there's lots and lots of studies of all kinds going on right now. And so we don't want to go too far in saying what it does, because a lot of that research is ongoing. And so we want to be careful there. Some of the research that we have done and completed is related to pathogen in some lab testing settings. So I want to share some of the results here with you and talk about what types of things needlepoint bipolar ionization has been tested against. So there's three types of testing. We won't go into too much detail here, but what we call sensitivity testing is a small petri dish type testing in a controlled environment. And so GPS has done testing on E. coli, staph. Those are the simulation testing. The light blue here are the sensitivity testing. So C. diff, Legionella, human coronavirus 229E, which is one that's been being used as a surrogate for COVID-19 by most people, because most people don't have access to the SARS-CoV-2 virus. And you can see the rate of reductions here are very high, and that's very good news. And so you can see on this far left that SARS-CoV-2 has actually been tested by GPS, and they're one of the first, if not the only, IAQ manufacturer to be tested against SARS-CoV-2 so far. And the performance is really great, 99.4% rate of reduction of the virus in a 30-minute exposure. I want to talk about this time in chamber exposure limit briefly, because a lot of folks do have questions about that initially. And the thinking is that, well, if I need that long of exposure, can it be any good? Because they think of typical systems like filters and UV being applied in a duct system where the air is passing by very fast. And obviously you're not going to have 15, 30, 60 minutes of exposure time when the air is passing a device that quickly. So the difference between ionization and some of the other technologies that we use to clean air is that ionization is delivering ions into the space. The cleaning effect of the technology is going into the occupied space, which is a totally different idea than filters or UV, because those are controlling contaminants right at the device. Air passes through a filter, it cleans what it can clean, and then it moves on. Air passes by UV. UV requires line of sight contact to be effective. As soon as the air is out of the line of sight of the UV bulb, it no longer has an impact. Ionization, on the other hand, continues to have impact as long as the ions survive. And the life of a single ion lasts between 5 and 60 seconds. Doesn't seem like that long, but again, if you think back to where we started the conversation about ion densities, what we're doing with ions is raising the steady state level of ions in the indoor space so that we can replicate some of the cleaner outdoor environments that we have on the planet. And so when we elevate those ion levels, even though individual ions are lasting 5 to 60 seconds, the reason why they dissipate or disappear is not because they simply vanish out of thin air. They actually are doing something. They're either attaching to an odor molecule or attaching to a particle or attaching to some kind of pathogen, bacteria or a virus. And so when they dissipate, that just means they're being used up. So when we measure ions in a space, we're actually measuring the residual ions, the leftover ions that haven't been used on something yet. So they just hang around until they get used. And so the more ion density we have in a space, the more cleaning potential we have with that airspace. Hopefully that makes sense. I like to think of it as just from a very basic standpoint of if somebody walks into a space and they cough and there's an infectious virus molecule that comes out, what happens to that? And we know some of it will drop with the droplets onto a surface, and in some cases it'll be airborne. And if it's small enough, it'll stay and linger around. And that's really what we're treating with the ionization system or any air cleaning system is what do we do with the airborne infectious particles? And those can hang around for hours or even days depending on the situation. And so if we can get a 99% clean time within 30 minutes, that's a huge, a significant improvement on what we would have without it. So that's way to think about it, is that this is really talking about time of exposure against the dose of ions per cubic centimeter. So hopefully that makes sense. If you have more questions about that, feel free to reach out because it's a very important component to understanding how ionization works in spaces on pathogens. But we will move on from there and talk about the final element of how ionization works, and that's odors. We'll just speak briefly about this. Buildings of all kinds have volatile organic compounds or off-gassing from building materials, human body. We put out odors, different things. And so the ions will break down those VOCs or those odors into less objectionable components, taking ammonia, for instance, into nitrogen, oxygen, water vapor. And so that's what's happening there. And probably the biggest anecdotal benefit of ionization is, hey, we've noticed that smell is gone, or we've been having exhaust fumes come into our building and now we can't smell them anymore. And so those are the types of things that people notice after installing ionization. Another great benefit, which we haven't really talked about, is allergies. A lot of folks comment that their problems with allergies have been greatly diminished when applying ionization. So those are some of the additional benefits along with particle and pathogen control. Lastly, I want to just touch on energy. As I mentioned, we're not promoting reduction of outside air at the moment, but moving forward beyond the pandemic, if we get to a point where we can put COVID-19 behind us, whatever that will take for that case to be, but eventually, hopefully we'll be in a position where we're back to controlling our buildings in somewhat of a traditional manner. And in those cases, we can look at reducing outside air. Just something to consider, because a lot of strategies that are being used right now, facilities are looking at them just being a drop in the bucket, a one-time thing, and they're going to spend a bunch of money right now to help the situation, and that's not going to be useful for them down the road because they're very energy intensive solutions or costly solutions that they don't want to be maintained beyond the necessary time period. Great thing about Needlepoint Bipolar Ionization from GPS is that there's almost no maintenance. It'll continue to work in a lot of different ways than just pathogen control far beyond the pandemic. So that's one thing to keep in mind. Now, very quickly, don't want to spend too much time on products, but want to show you a couple things. It's particular, this slide, these are self-cleaning devices. And you can see here, there's 2 needle clusters and a wand. We'll talk about that in a minute. These 2 on the corners are for, or on the edges are for going inside of existing HVAC equipment of all different kinds. Package rooftop units, fan coils, heat pumps, most of the types of equipment you find in school facilities. The middle one here is wherever you don't have a unit to put a device in, an existing HVAC unit, this can go right into the ductwork. The model is a DM48, it stands for duct mounted. And so all they do is cut a 4-inch hole in the duct, slide this in there. It's got a nice gasketed seal. It's weather tight, so you can put it in exterior ductwork. Again, with these 3 very versatile solution options. The next ones I want to show you are for kind of the fringe type systems, But if you're in an older building, you might have systems that don't have ducted systems. So for a ductless or very small systems, these are called the Irid. They're ribbon style units, and they're a ribbon. They roll out on the face of that ductless unit, and they're very easy to install. And then this unit is on the other end of the spectrum for large, big system air handlers, maybe in some high schools, places like that, where we want to apply lots of ionization to a large system. We don't see these typically in schools, but on occasion they make sense. No matter which of these items you're using, one of the great features is that they can connect universally to whatever power source is nearby, just about. Anywhere from 24 volts all the way up to 240 volts. It can be AC current or DC current. Your facilities people will know what that means if you don't. But all that means is you don't have to bring a new power source because the power draw is very low, anywhere from 4 watts to 15 watts. And it's a very versatile, easy product to install. There are some measuring devices, sensors. We won't talk about those today. And then we'll get you a copy of this presentation for anybody that wants it. You can send me an email at dan@norburn.com, and I'll be happy to send you links to these. But we'll move on. There's some measuring devices we use. I want to get to some case studies to finish up. Yes. I guess real quick, let me touch on this auto cleaning feature because it is important. In these devices, one side of this is a carbon fiber needle brush cluster, and this side is doing positive ions, this side is doing negative ions. And what happens is if you have a single polarity emitting ions, it will gradually attract dust and other particulate that's of the opposite charge, and so it can get dirty. And when it does get dirty, the ion counts go pretty much to zero, the output. And so in order to keep the output high on these all the time, GPS has developed this auto cleaning wiper blade. Comes pre-programmed to automatically rotate every 3 days or so. And it just wipes those brushes clean and keeps them generating ions all the year long. Very, very key feature there. Here's some installation examples. So you've got duct mounted units here right in the ductwork. And then on this side, this is an FC24, a self-cleaning model right on a fan coil unit. And then here's some larger of the air handling systems installed. Now, just quickly through a few additional resources, I want to share some of these case studies with you. And again, these are all available on the GPS website, which I think I will just show you where those are at the conclusion of the workshop here, so you know how to get to them. This is an Amalie Arena. It's in Tampa Bay. So again, example of a large space. Here's Children's Hospital, where they used ionization to remove some odors. A clean room example where you would think particulate's already very clean. Well, they actually installed this to control some odors, and by chance happened to notice, wow, our particulate counts went down even further by almost 90%. And that's in a space that's doing 40 air changes of HEPA filtered air. So that goes to show that the ionization can just further improve whatever existing filtration your facility has. This is a restaurant, or sorry, this is an office. Children's daycares have been using them, very similar function to schools. Universities are big. This is the University of Maryland, where they verified lower particulate counts and no ozone. And initially they were using it to control exhaust odors. Notice that they were remediated within a day. And then the last one I wanted to show you here, or one of the last, is another high school, and Greer High School in Georgia. And they've done a ton of schools in Georgia. A lot of the districts are mandating this technology because it's been so beneficial for the students and the staff. And then here's a pet daycare. And then airports, again, as I mentioned before, there's a Calgary International Airport. It has this installed with 96% particle reduction within a couple days. Same for Edmonton. Those have been fast. So that is our formal presentation. Thank you for tuning in and being attentive. I do want to share with you the website, Global Plasma Solutions. So if you look up here, it's just do this again, globalplasmasolutions.com. If you go here, that video I showed you at the beginning is right here in how it works. And You can play that video right from here if you want to go watch that again. If you want to check out the product line that I just covered with you, you can come in here and look at all the different products. And then if you want to get a little more detail, you go over here to GPS information, GPS library. There's a whole slew of documentation and information here. Case studies we just looked at are all copied in right here. Some additional ones. Here's another link to that video. Product data sheets, a lot of different stuff. Industry research, if you're curious what's going on out in the world, what other articles are there? Here's a lot of references to topics like that. Academic letters, other case studies, things of that nature. So please feel free to take advantage of that website, make it useful to you, and definitely reach out to us here at Norbert Equipment. I would love to help you out. You can give me a call on my direct line, 794-2649, or hit me up at dan@norburn.com. Thank you very much for your time. We appreciate the opportunity to work with ISBA, and we hope you've had a great convention and that this has been a great workshop learning experience for you. Thank you.